Hello guys, welcome to Tech with Praise James. In this channel, I explain AI and machine learning jargons using storytelling. Call me best friend. Imagine walking into a small grocery store with, let's say, 10 items. You can quickly find what you're looking for, right? Good. Now, imagine walking into a supermarket with like 10,000 items. Where do you want to start? Obviously, finding what you're looking for will become overwhelming. This sort of what happens in machine learning. If a data set contains so many features, it becomes difficult for the model to learn useful patterns, and it leads to what we call the curse of dimensionality. In today's video, I'm going to teach you what is the curse of dimensionality, why it is a serious problem in AI, and how it can be fixed. Come with me, besties. So before I actually go into details of what the curse of dimensionality is, there are 4 terms that I will be using a lot throughout this video that I want you to understand beforehand. Number 1 is features. Features is basically the input values that is given to a machine learning model that it learns from to be able to make predictions. It learns from the patterns within those features. So basically, if you have a tabular data, the features are the columns. Number 2 is data point. Data point is basically any identifiable element within a data set. Number 3 is observation. Observation is a complete single set of data points. So if you have a tabular data, features are the columns and observations are the rows. The number 4 is sparse. When I say the data set is sparse, it means that the data set lacks significant information. So now that we have those 4 terms out of the way, let's discuss what is the curse of dimensionality. So what is the curse of dimensionality? It's basically a situation where as the features in the data set increases, the data becomes sparse, meaning the distance between data points in the data set become meaningless. So the model cannot learn from the patterns to be able to make predictions. So basically, the more the features, the harder it is for the model to learn anything sensible or relevant to be able to make predictions. So when a data set contains a lot of features, we call it a high dimensional data set. So this usually happens with medical records, right? So let's say a data set has 500 columns, which are features, and 10,000 rows of observations. That's a high dimension data, and that's going to stress the model in finding tangible patterns that it can use to make future predictions. So let me explain this curse of dimensionality with a real world situation. Now, if you want to visit a friend that's living the same street as you, they just have to give you the house number. Even if it's just a number, you can easily locate them, right? Good. Now, if your friend is living in another country and they tell you the house number, the street name, the state, the bus stop, you have more information, but it's still difficult to be able to locate their friend. Let's say you not even enter the one that there are 5 streets with that same name. Your friend will tell you, oh, it's the street with the yellow house. It's be the friend. Will you have to go to 5 different streets before you now even know where the yellow house is? So even if you have more information, it's still difficult to locate the house. When you had just a number, you could. You would think that more information would equal faster solutions to your problem, but actually it just keeps compounding the problem, and that's how it works in machine learning. In machine learning, more features does not equal better performing model. It doesn't. So now that you know what the curse of dimensionality means, why is it a problem in machine learning? Number 1, it would mean that the model requires more data. Since it's not learning anything tangible from the one it's already presented with, it would require more data, but more data would just be more problems. That's bad. Number 2, it would mean that the model training time is going to be very long because it's taking so much time to be able to see something like it's begging the data, show me something, I'm begging you. And this would mean that more computational resources will be spent. Now tell me, nobody likes to spend money that are not using to buy clothes like Misha. Then number three, it leads to what we call overfitting. So it's basically a situation where instead of the model to learn patterns that it can use to make predictions, it will be memorizing the data set. It will not learn anything sensible. It will just be packing it in its head like, yes, I have all these things in my head. But when you now bring a new situation for it to be able to practice what it has learned, it will not fail the exam. So that's what is overfitting, and that's what happens when there is the curse of dimensionality. But you know one thing I like about machine learning? When there's a problem, there's a solution close by. So how can we solve the curse of dimensionality? There are two popular ways to break the curse of dimensionality. Somebody shout hallelujah! Number one is feature selection. It's basically choosing the most important feature that actually impact decision making. You ask yourself, I have 500 features, but which feature here right now impact decision making? It's basically prioritizing the features that actually impact the decision the most. So let's say you're working on a scholarship prediction model and your data set contains features like height, weight. Those information, they don't affect whether the person should get a scholarship or not. So those features can be discarded and more focus can be put on other ones like their grades, if they are punctual to school, those kind of actually important stuff. The second solution is through dimensionality reduction techniques like PCA, which stands for principal component analysis. It's basically a technique that reduces the features in the data set while still keeping relevant information. That's more advanced, and I won't be discussing more about it in this video. I will try to create a separate video explaining how the technique works. So basically, what this course of dimensionality teaches us is that more information does not equal better performing models. It's actually relevant information that equals better performing models. So that's all I have for you today. Thank you for staying with me to the end. If you found this video helpful, please like, share, and subscribe. Your support means the world to me, okay? And make sure you stop by next Friday. I will explain another AI jargon for you. If you have any specific one you want me to explain, please let me know in the comments. And I promise I'll do something about it. I hit those notes, baby! So don't miss our friendship dates. Bye!